Hi everyone, let's make sure that you have puzzle number 1 on the right track. So you're given the equation y equals negative x squared, or in this case we label it with an f of x equals negative x squared. If we go to our table, we know that the easiest point to plot is the point 0, 0. And so if we go, whoops, where did these negatives come from? This should be positive 1, positive 2, positive 3. But if we put in 1 into the equation, 1 squared is 1, and then make that negative, that should be negative 1. 2 squared is 4, made negative is negative 4, and positive 3 squared is 9, made negative is negative 9. So we know that it's symmetrical, so the y values will be the same on both sides. Make sure these are positive. This is supposed to be negative 3x, negative 2x, negative 1, 0, 1, positive 2, positive 3 as the x values, and then these are our y values. And then we can plot them on our graph. So here is the point 1, negative 1, 2, negative 4, and then 3 would be down at negative 9. Same thing over here, negative 1, negative 2, negative 4, and negative 3, negative 9. If we kept going, positive 4, negative 16, negative 4, negative 16. And then we can, once we have our graph and our table, we can start to see the key features. So our key features, if we forget them, are all listed on the front. So I'm going to just list them and start working on them. Our slope is not relevant. It's a bowl in the shape. It's upside down, so that would be concave down. And the number in front of a right here, the number in front of x squared is our a value, and that is negative 1. Our vertex happens here at 0, 0. Our axis of symmetry cuts our parabola in half, so that happens at x equals 0. Our x-intercept happens when y equals 0, so we could put 0 equals negative x squared and solve, but we know from our graph that it's right here. Our x-intercept and our y-intercept are at 0, 0. Our domain, x can be anything because there's no number I can put in this equation where math blows up and it goes all the way to the left and all the way to the right. So the domain is x can be anything, or x exists in all real numbers. And our range is, find our vertex, our y value of our vertex is 0, so then the parabola happens below that point, so it would be y is less than or equal to, I missed that, less than or equal to 0. So you should have a little line under that less than symbol. Reading function notation, if they give us an x value, f of x is negative 10, I put that into my equation. Negative 10 squared is positive 100, mid negative is negative 100. One other thing that our puzzles have in the upper right hand corner is, are we given this in standard form, ax squared plus bx plus c, or are we given it in a different form such as factored form or vertex form? And in this case, where we can see that it's just a standard form, here's your ax squared plus bx plus c. Your b value and c value are 0 because they're non-existent here, and our a value is equal to negative 1. So I can circle it was given in standard form, and I can fill in my values. Going to reading function notation, if I read this left to right, so I trace my pencil here, and I go left to right, here my pencil's going up. I am increasing, so my rate of change, f prime of x, is greater than 0. Here it stops, so f prime of x equals 0, and here if I move left to right, I'm moving down. So f prime, the rate of change, is less than 0. Function notation compared to x squared, which was our original graph on the front page, right here. Compared to this graph, what happened to ours here? How is it different? And here, it was flipped upside down, or it was flipped over the x-axis. So here you can find reflected over the x-axis. Did it get stretched vertically, or does it follow the same rhythm of over 1, up 1, over 2, up 4? And there was no stretching of that rhythm. It was over 1, down 1, over 2, down 4, over 3, down 9. It wasn't shifted up or down. Our vertex is still at 0, 0, and it wasn't shifted to the left or to the right. Our minimum maximum still happens at 0, or our axis of symmetry happens at 0. So the only thing that really happened was it got flipped upside down. Last but not least, with your problem solving and algebraic fluency, it gives you another graph, G. So we have f, which is equal to the pattern negative x squared, and g, which is equal to the pattern x. Find when those two patterns are equal to each other. So I'm putting f of x equals to g of x, so the pattern negative x squared, which is f, equals x, which is g. So now I have a quadratic puzzle. I'm going to set it equal to 0. So I'm going to move this negative x squared over to the right-hand side. 0 equals x squared plus x. And then working on recognizing that you can work easier, smarter, not harder. These two both have an x in common, so I'm going to factor that out. I'm going to undo the distribution. And then I'm left in parentheses with x plus 1. So if I did my rainbows, I would get x squared plus x here. And now I have a number times a number equals 0. So either x has to equal 0 or x plus 1 has to equal 0. So either x equals 0 or x equals negative 1. I can verify that on Desmos by graphing the left-hand side, which is, whoa, let me redo that. Add note. Left side is g of x equals x, and the right side, f of x equals negative x squared. I could do this on my TID4 too. y1 equals x, y2 equals negative x squared. And it will show me both graphs. And if I press in the intersection, sure enough, x equals negative 1 and x equals 0. So I put a little sketch there. Dear Lord, this is wrong too. My g of x I did incorrectly. It should be increasing to the other way. So make sure you fix that as well and detail why. So that is puzzle number 1 with some good attention to detail on fixing this in your packet and fixing this graph in your packet. So you have the correct x equals negative 1 over here and x equals 0 here.